Hello, my good people. Welcome again to my YouTube channel that is on the Big Structure Hub. This is a place where you learn, build, and innovate. Today, I want to solve problem number 2 under moment distribution method. And this is a frame, and the question is from past paper, and it carries 20 marks. So the question reads, analyze the beam shown below, and hence draw bending moment diagram indicating all values at critical points. So this is the frame that is on the board, as you can see. So this frame is supported at point B. At point B, this is a pin support. Again, at C, it is supported at C. This is a simple support. At D, as you can see again at D, it is a pin support. And then at E, so at E is a fixed support. Again, this portal frame has both UDL, which is uniform distributed load, and a point load. Also, a portal frame is overhanging with a portion BA on the left side of the beam. So it carries a UDL of 15 kilonewton per meter, spanning at 6 meters. Again, 15 kilonewton, which is a point load. It is overhanging from B at a distance of 1.5 meters. It also carries a point load of 50 kilonewton placed at 3 meters from E and 2 meters from D. Again, it carries a point load of 10 kilonewton placed at 2 meters from E and 4 meters from D. So let's see how we can tackle such a problem. Solution. So we begin by fixed end moment. So fixed end moments. So we'll begin by span BC. So under span BC, we have this one. So this is 6 meters, and this is A, or this is B, this is C. So this one will be M, F, C, B, and this one M, F, B, C. So during the exam, it's not necessarily to draw this. I'm just doing it for an explanation. So for you, you'll just calculate direct from here your fixed end moment. So here you have 15 kilonewton per meter, like that. So M FBC, this one is equal to minus WL square over 12, which is equal to minus 15 times 6 square over 12. So the answer is, punch your calculator, 15 times 6 square over 12. So the answer is negative 45. Negative 45 kilonewton meter. We proceed to MF. CB. As you can see, MFCB, the formula will just remain the same, but the sign will change to positive. So there is no need of repeating ourselves. We just change this answer from negative 45 kilonewton meter to positive 45 kilonewton meter. So the answer is 45 kilonewton meter. We proceed to M, F, B, BA. So MFBA is this one, BA. So here, this moment is moving in clockwise direction like this. So it means is a positive moment. So we will have is equal to plus WL, which is equal to 15 times 1.5. So this one is equal to, again you punch your calculator, 15 times 1.5, 22.5 kilonewton meter. We proceed to span CD. So CD, if you can draw, so no need to draw in your exam. So this is 3 meters, this is 2 meters, this is 50, and here we have M, this is D, C, M, D, C, and here M, C, D. So MF, CD is equal to minus W, A, B square over L square. So this one will be minus 50 times 3 times 2 square over L is this distance 3 plus 2, 5 square. So the answer is minus 50 times 3 times 2 square over 5 square. So the answer is negative 24. Negative 24 kilonewton meter. So negative 24 kilonewton meter. We proceed to MFDC. So MFDC is this one. So this one will be positive plus W A square B over L square. So this one will be 50 times 3 square times 2 over 5 square. So the answer is, find your calculator again, 50 times 3 square times 2 over 5 square. So that is 36. 36 kilonewton meter. We proceed to span CD. So span CD, if we can draw here, so this is C, this is E, CE, not CD, and we have 10 kilonewton, and then from C to 10 kilonewton is 4 meters, and then from E to 10 kilonewton is 2 meters, like that. So here we'll have M, E, C, and here M, C, E. So MFCE is equal to this one, minus WAB square over L square, which is equal to minus 10 times 4 times 2 square over 6 square. You get negative 4.44 kilonewton meter. MFEC equals to WA square B over L square, which is equal to 10 times 4 square times 2 over 6 square is equal to 8.89 kilonewton meter. We proceed to stiffness factors. Stiffness factors, which is K. So we will begin by K1. K1, which is equal to KBC. So KBC. So this one, as you can see, KBC, this is a simply supported beam. So we will have 3 over 4 I over L. So 3 over 4 times I, 2 over L, 6. So this one will be 3 over 4 times 2 over 6. So 1 over 4, like that. We proceed to K2. K2 will be KCD. As you can see, again, CD is a simply supported beam. So we will use 3 over 4 times I over L. So 3 over 4 times I, which is 1, over L, 3 plus 2, 5. So this one will be 3 over 20, like that. We proceed to K3. K3 is equal to KCE, which is equal to, as you can see, this one is fixed. So it will be I over L. So this one will be I is 1, and L, 2 plus 4, 6. So that is our K3. After stiffness, we proceed to distribution factors. Distribution factors, which is DF. Distribution factors. So we will begin by this point B. So D distribution factor BA is equal to 0 because this is an overhanging portion and it does not resist any moment. So our distribution factor is 0. Distribution factor BC is equal to 1 because this distribution factor for a simply supported end is always equal to 1. Again, distribution factor DC is equal to 1. Similar case to DFBC. Again, this distribution factor is EC is equal to 0 because it's a fixed end. We proceed to distribution factor CB. So CB will be KCB over KCB plus KCD plus KCE. So this one will be KCB is 1 over 4 over 1 over 4 plus KCD 3 over 20 plus KCE 1 over 6. So our distribution factor will be, just check your calculator, 1 over 4, you divide 1 over 4 plus 3 over 20 plus 1 over 6. So the answer is 15 over 34. Distribution factor CD, it will be KCD over KCD plus KCB plus KCE. So this one will be KCD is 3 over 20 over 3 over 20 plus KCB, which is 1 over 4, plus KCE, 1 over 6. So the answer is, again, punch in your calculator, 9 over 34. So 9 over 34. We proceed to KCE. The distribution factor CE. So this one will be KCE over KCE plus 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 KCD plus KCB. So this one will be KCE is 1 over 6, 1 over 6 over 1 over 6 1 over 6 plus 3 over 20 plus 1 over 4. So this one will give you, find your calculator again, 5 over 17. 5 over 17. For us to know if our angles, our distribution factors are correct, if you take this, add to this, add to that, it should give you 1. So plus 9 over 34 plus 15 over 34. So the answer is 1. So we are on the right track. After calculating our moment distribution factors, now we'll draw this table. So this is our table as a result of this total frame. So this table will have joints, members, distribution factors, and fixed end moment. So as you can see, if we begin by joint B, this is joint B. Joint B has member BA, this is BA, and BC, this is BC. We proceed to joint C. Joint C has member CB, this one, and CD, this one, and CE, this one. We proceed to joint D. Joint D has only one member, which is member DC. Member DC. Again, we proceed to the last joint, which is E. It only has one member, which is member EC. EC, like that. So after that, we come to distribution factors. Already we calculated our distribution factors, and they are on our board, as you can see. So BA, distribution factor BA, as you can see, BA 0, write it there, 0. BC, this one, 1, you put there 1. CD, CD 15 over 34, like that. CD, CD, this one, 9 over 34, like that. CE, CE, 5 over 17. Then DC, DC, 1. Then EC, 0. Having done so, we proceed to fixed end moment. Again, we have calculated our fixed end moment. This is our fixed end moment. So we fill our table with what corresponds to members. So member BA is this one, 22.5, 22.5. Member BC member BC, member BC. So BC negative 45, like that. Member CB positive 45, positive 45, like that. Member CD negative 24, negative 24. Member CE, this one, negative 4.44. Member DC, positive 36. This one. Member EC, member EC, this one, 8.89. After that, follows next is now to start balancing this fixed end moment. And if you can observe our frame, you notice that we have thin support B, again thin support D, and fixed support E. For this case, support D, you know that for a simply supported support or a pinned support or a hinged support, its moment is always equal to 0. So for this case, moment here at D is supposed to be 0. So what are we supposed to do here? We will come here at D, this is D, and release this fixed end moment. So we will release D, release joint D. And how are we releasing this joint? We release this joint by adding or subtracting any figure from 36. And that the answer should be equal to 0. So what we do, we will release by negative 36, such that if you add these two, it should give you 0. And then after there, you carry over. Carry over. So you will carry a half of this to the opposite member of DC. So the opposite member of DC is CD. So you will carry a half of this to this member. So that one will be 18. Negative 18. So remember, it is a half of this. So negative 18. After doing so, we will now find the initial moment, initial final moment. So we will add 22 plus 0 plus 0, that one will be 22, 22.5 minus 45 plus 45. Again, minus 24 minus 24 plus minus 18. That is minus 42. Minus 42. Here is minus 4.44. And then here is 0. Here is 8.89. After calculating our initial final moment, as you can see on the board, what follows next is balancing and carrying over. And what is balancing? As you can see, joint B, it has two members, member BA and BC, and also joint C, it has three members, CB, CD, CE. So it means if you add BA and BC, that is fixed end moment, it should give you 0. And if the result is not equal to 0, then it means this joint B is not in balance. So it means you have to distribute the result by multiplying with the distribution factors of each member to make it balance. So, for example, joint B, we have 22.5 plus minus 45. So it should give you 0. Let's see. 22.5 plus minus 45. So the answer is not equal to 0. As you can see on the calculator, so the answer is negative 22.5. Now, what you are supposed to do, you are supposed to take this negative 22.5 and balance to its member of joint B, that is BA and BC. So you always take the opposite sign of your answer. For example, we have negative 22.5. So the opposite sign of negative is positive. So you will take positive 22.5 and distribute to each member, BA and BC. So you will take positive 22.5 times 0. The answer is 0. Let me show you. The answer is 0. So you put there 0. Again, you take positive 22.5 times 1. The answer is 22.5. You write it there, 22.5. Now we have distributed 22.5 equally to member BA and BC. We proceed to joint C. Joint C, we have member CB, CD, and CE. It means if we add these initial moments for these members, it should give you 0. For example, 45 plus minus 42 plus minus 4.44. And if the answer is not equal to 0, it means this joint is not in balance. So you have to distribute your answer to make it balance. So let's proceed and see how we can do it. 45 plus minus 42 plus minus 4.44. So the answer is not equal to 0. So the answer is not equal to 0. So you can see on my calculator, the answer is negative 36 over 25. So you will distribute the opposite. You will distribute positive 36 over 25 by multiplying each distribution factor to make it balance. So we start by positive 36 over 25 times 15 over 34. So the answer is 54 over 85. Again, you can see 54 over 85. Again, you take 36, positive 36 over 25 times 9 over 34. Again, the answer is 162 over 425. I hope you can see 162 over 425. Again, you take 36 over 25 times 5 over 17. So the answer is 36 over 85. 36 over 85. After balancing B and C, the next step is to carry over, and the carrying over, you will carry over uh, what you have balanced to the opposite member of that member. For example, we have member BC. The opposite member of BC is CB. So you will carry a half of this 22.5 to the opposite member, which is CB. So you take 22.5, you divide by 2. So the answer is 45 over 4. 45 over 4, as you can see. Again, you take a half of this CB to the opposite member, which is BC. So it will be 54 over 85. 54 over 85. You divide by 2. So the answer is 25 over 85. 27 over 85. You proceed. You come to this member CE. For member CD, you cannot carry a half of this value to DC because our DC, we have already released this joint, and we know for a pinned support or a roller support or a simply support, the moment is always equal to 0. So here, there is no way you can carry a half of this value to this member. So you go to CE. CE, you will take a half of this value to the opposite member, which is EC. So you take 36 over 85, you divide by 2. The answer is 18 over 85. Again, you can see it. We proceed again. We will keep on repeating the same procedure until we reach to the smallest value for carryover, and that is where we will have our final moment. So let's proceed. So after carrying over, we again come to balance, and the balancing will take this value, which is 27 over 85. It is positive 27 over 85. So the opposite sign of positive is negative. So you take negative 27 over 85 and distribute equally to each of this member in joint B. So this one is 27 over 85. So you take negative 27 over 85 times 0. It is 0 here. Negative 27 over 85 times 1, we have remain the same value. Again, we come to this one, to this. We will balance this value, which is 45 over 4, to each of these member. So you take the opposite sign of here. We have positive 45 over 4. So the opposite sign of positive is negative. So you take negative 45 over 4 and distribute equally by multiplying each of these distribution factor to each member respectively. So we begin. Negative 45 over 4 times the distribution factor of CB is 15 over 34. 15 over 34. The answer is negative 675 over 136. Again, I will show you. So negative 675 over 136. You write it there. You come to this one. You take negative 45 over 4 times 9 over 34. The answer is negative 45 over 136. Like that. We come to the last one, which is CE. Negative 45 over 4 times 5 over 17. The answer is negative 225 over 68. I will show you again. Yeah, like that. After every balancing, what follows is carrying over. So we will carry over again a half of this value to the opposite members. For example, we come to BC, we have negative 27 over 85. A half of this is 27 over 170. So we carry it to the opposite member, which is CB. Half of this to the opposite member, which is BC. This is the value. Again, half of this to the opposite member, which is EC. Like that. Again, we balance. So balance will take this value, which is 81 over 23 over 12, it is positive. So we take this, the opposite sign of positive, which is negative. So the negative 81 over 23, 12 distribute equally to these members by multiplying with distribution factors. So negative 81 over 23 over 12 times 0 is 0. Negative 81 over 23, 12 times 1 is this one. So like that. Again, you come to this one. Take the opposite sign of this value and multiply it with its with the distribution factors of each member. For example, negative 675 over 554 times 15 over 34, you will get this value. You do it the same, negative 675 over 554 times this, you will get this value. Negative 675 over 554 times this, you will get this value. Then what follows next? After balancing, we always carry over. So a half of this to the opposite member, which is BC, this is the value. A half of this to the opposite member, this is the value. A half of this to the opposite member, this is the value. After doing so, after reaching to a value of carryover which is so small, for example, like 0.273 or 0.00, you can now stop there and do the final moments or calculate the final moments. So the final moment is the sum of these moments from initial final moment up to your last carryover. For example, 22.5 plus 0 plus 0 plus 0 plus 0. We have positive 22.5. Negative 45 plus 22.5 plus 27 over 85 plus minus 27 over 85 plus minus 675 over 275 plus 675 over 275 plus 81 over 2312 plus minus 81 over 2312 plus minus 0.27371, you get negative 22.5 to one decimal place. You do it the same to this. This plus 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 this, you will get 52.5. Again, you come to this one. Negative 44 plus this plus this plus this plus this, you will get negative 44.9. Again, you come to this one. Negative 4.44 plus this plus this plus this plus this, you will get negative 7.60. You come to this. 0 plus 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 0, you get 0. You come to this one. 8.89 plus this plus this plus this plus this, you will get 7.3. So this is our final moments. And if you want to prove your answers, if it is correct or wrong, so 22.5 plus minus 22.5 automatically is equal to 0. Let's come to C. Take 52.5 plus minus 44.9 plus minus 7.60. It should give you 0. Let me punch my calculator to prove it. So the answer is 0. I will show you. I hope you can see 52.5 plus minus 44.9 plus minus 7.60 is equal to 0. So that is it. What follows next is to draw the bending moment diagram for a portal frame. So let's see how you can draw that bending moment diagram and indicate all critical values. For us to draw bending moment diagram, we need, or we are supposed to calculate a free span moments. So for free span moment, we have span BA. The formula is minus WL, so which is minus 15 times 1.5, get negative 22.5. We proceed to span BC. Span BC is a UDL. The formula is WL squared over 8. So the answer is 67.5 kilonewton meter. We proceed to span CD. WAB over L. The answer is 60 kilonewton meter. Span CE. WAB over L. And the answer is 26.67 kilonewton meter. After that, we will draw free span moment diagram. And this is how we draw free span moment diagram. So for span BC, we have 67. BC, we have 67.5. So we will approximate like that. Again, we proceed to span. Span CD. Span CD, you have 60 kilonewton meter. So this one will be a triangle. So we have 60 somewhere like there. So this is 60. And then we have span CE, 26.67 kilonewton meter. Again, so we approximate like that. After that, now we can draw our bending moment diagram depending on the value we calculated in our table, our final moment value. So I will begin by at this point B. At point B, we have BA as 22.5. So you will approximate along this line. Where you think 22.5 is, let's say is here. So 22.5. 22.5. We proceed to CB, 52.5. So CB along this line. So remember this was 67.5. So, and this was 60. And this one is 57. 52.5. So around there. 52.5. We proceed to span, we proceed to CD, 44.9. CD, 44.9. So we approximate along this line. So 44.9, like that. And then we proceed to CE or EC, 7.3 along this line. 7.3 around there. So we will join this. This one will be a curve. So this one is a curve. And this one is an inclined line up to 0. And then we have this one. like that. And we shared our respective areas, and our question ends there. So this is negative, negative, positive, positive, negative, positive, negative. So that is our final moment. So our question ends there. And for those who have not subscribed to my channel, please do so and hit the notification bell so that you may be the first person to be notified when a video is uploaded. We meet again in my next session.